Hi, welcome back. This is Professor Ridge and today's lesson on section 9.4, Properties of Logarithmic Functions. So the product rule for logarithms, if you have any positive numbers m and n and a, which is not equal to 1, the logarithm of m times n, base a, is equal to the log of m, base a, plus the log of n, base a. So if we remember that logarithms are exponents, and if we think of, what I always tell my classes is that the logarithm rules are basically exponent rules, just in disguise, because, let me show you the proof of this. So if we say log, how should I do this? Log, we'll start with the right side. Log of m, we'll call that x, and we'll let log base a of n be equal to y. Then from our definition using exponent rules, a to the x equals m. Writing it as exponents, exponential form, and a to the y equals n. So if I asked you to multiply m times n, that's going to be a to the x times a to the y, and using exponent rules, mn is equal to a to the x plus y, using exponent rules. And then we go back to our defining statement about logarithms and convert this to log, so that tells us log base a, remember log equals the exponent, and then convert x by we defined x to be log base a of m, and we defined y to be log base a of n. So that's the proof of that rule. That's where it works. So really what it is again, it's exponent rules just kind of disguised. You don't really realize that you're doing it that way. So basically we take, if we're multiplying numbers inside, so log, say, base 2 of, say, 16, well, that's the same thing as log base 2 of 8 times 2, which is the same thing by this rule, log 2 to the 8 plus log 2 to the 2. Now, I would never do this, right, because I'm just showing you that it works. So we know that 2 to what power, so if I asked you to do log base 2 of 16, you should tell me, well, 2 to what power is 16? And the answer is 4. Now, just to show you this works, I also know that 16 is 8 times 2. And then by this product rule for logarithms, I can split it up into log of 8 plus the log of 2. And 2 to what power is 8? Well, that's 3. 2 to what power? Well, that's the inverse one. That's just 1. 2 to the first is 2. And then 3 plus 1 is 4. So it definitely works for that one example, and I proved it above, so there should be no doubt that this rule works. Okay, so let's, usually we use this rule in the other direction, so express as an equivalent expression that's a single logarithm. So if I'm adding logarithms, see, we're adding, Now the key is that the other thing is the bases have to be the same to use this. And if they are, then I can combine it using the product rule, and you leave the base alone, and then you're going to multiply the numbers inside. So it's log base b of 130. Okay? So typically that's the way we use it, but we can use it the other direction also. Okay, the next rule that we need to talk about, and then we'll do some exercises from the book, is the power rule for logarithms. Okay, so for any positive number m and a, and again a can't be 1, and any real number p, so p can be any number, a has to be positive and it can't be 1, and m has to be positive. So log of m to the p is equal to, and then what you do is bring that power out in front and multiply it by the logarithm. So again, if I think about exponent rules, if you took an exponent, if you did a power to a power, you multiply the powers. So again, if I think of a logarithm as an exponent, as a power, see, I'm going to do the power times the power. So it's the same idea. And if you do the proof, which I won't do, you can see where it comes from. Okay, so I just kind of think of exponent rules. If I do a power to a power, I'm going to multiply the power. Okay, so for logarithms, you basically take the power of the number inside and bring it out in front. So typically, you would see, well, I'll show you an example. Okay, so the quotient rule for logs, for any, okay, so the quotient rule again, for any positive numbers m, n, and a, and again, a cannot equal 1, log of m divided by n is equal to, now again, if I think of exponent rules, if we divide the numbers, what do we do with the exponents? If you divide the numbers, they have the same base, you subtract the exponents. Well, that's what this rule is. So if I divide the numbers inside, I split it up and divide the logarithms. Subtract the logarithms. So if I divide inside, I can subtract the logarithms. Okay? Which should make sense, because when I multiply them, I add them. I add the logarithms. So if I multiply the numbers inside, I add the logarithms. If I divide, I subtract. And if I do a power inside, I bring the power out in front and multiply. Okay, so those are the three basic rules. And then I already wrote this one down, but I'll write it again. It's if you take a logarithm of a base to an exponent. Okay, so again, log of a to the k. Now, if that matches the base, if those two bases match, they kind of cancel each other out, and you just get the power. That's just the power. All right, so let's try some of these and see how we do. Some exercises. All right, so if we look at number 18 from the book, it says log base b of t to the fifth. And again, what you're going to do is you're going to take the power and bring it out in front. So it'll be 5 times the log. You don't have to write the dot either, by the way. Okay, so it's simple as that. Number 22, log base c of m to the negative 5. Take that negative 5, bring it out in front. So it's negative 5 times the log base c of m. And that's it. Okay, let's look at 24. So now we want to express it as an equivalent expression with the quotient. So we've got log base 3 of 29 13ths. Oh, I wrote that wrong. It says express as an equivalent expression that is a difference of two logarithms. So we're starting with it as a quotient. So now we're going the other direction and doing it with the quotient rule. So this is going to be log base 3 of 29 minus log base 3 of 13. Okay, and that's all we wanted to do there. Now you got to be able to work both directions too, where you're going to split these up and then put them back together. So let's look at 33 to 46. Okay, so number 36, log base a of x squared y to the fifth. So I want to split this up into simpler logs. So this is times right there in the middle. So I can split it up into log base a of x squared plus log base a of y to the fifth. And now I'm going to use the power rule and bring both of the exponents down. With a little practice, you can just do both of those steps at once. So just know the powers will come out in front. And then times, you're going to split up with plus. Divide, you'll split up with minus. Okay, and that's my final answer there. So that's making the logs more simple. The expression's more complicated because you got two logarithms and you got multiplying. But anyway, there you go. Let's try number 42. Now what I tell my class, usually, I'll show the step here. So first thing I'm going to do is I'm going to split it minus the top one minus the bottom one. So log base b of w squared x minus log base b of w cubed z. And then we're going to split it up. We got log base b w squared plus log base b of x. Now you got to be careful because this, you got to think of this like in parentheses, and I'm going to distribute the minus sign. So it's minus log base b of w to the third minus log base b of z. Now bring all the powers out in front. And again, with practice, we could probably have done this all in one step. And that's usually what I show in class after I do it once. So all the powers will come out in front of each log, and then the ones on top are plus and the ones on bottom are minus. So that's kind of the way I think of it. So I can just go straight to this last line, bring the 3 out in front. Okay, and there you go. Alright, now, so that's pulling them apart. You got to be able to put them together. So depending on what you're doing, sometimes you want to pull them apart to simpler logs, and sometimes you want to slam them all together to make one logarithm. So it just depends on what we're doing. Okay, so we want to put this together. So again, my first thing is I'm going to use the product rule in reverse and get those as powers. Okay, remember 1/2 power is the same thing as square root. So you can write it as 1/2 or square root. That's your choice. I'll just leave it as 1/2. Now we're adding the logarithms. So when you add the logarithms, you can put them together and multiply the numbers inside. So it'll be m squared times the square root of n. Or you can write it as a 1/2 power. And there you go. That's one logarithm, and there's nothing to simplify on that, so we just leave it like that. Alright, number 50 on this one, again, you got to think square root is a half, is to the 1/2 power. Well, I guess we don't need that because we're putting them together, not pulling it apart. Okay, so when we subtract, remember we divide. So we're going to get log base a of a over square root of x divided by square root of ax. So we need to do some scratch work and simplify this. So I'm going to put that over 1, flip it over. So let's see. Okay, so a over square root of x, so this is just scratch work here, times, flip that fraction over, that's 1, or a over, I got 2 x's inside the square root, so the x comes out. I want to rationalize my denominator. So that's going to be a square root of a over ax, because 2 a's inside make 1a out, and then that cancels out. So again, that's scratch work. Alright, so the inside simplifies to square root of a over x. Okay, so on this one, I'm going to start inside the parentheses first. So let's see, that would get me log base a of 2x, leave that one alone. I'm subtracting, so I can divide the numbers inside, subtracting logarithms. Now I'm going to use my power rule, bring this up. So x over y cubed is going to be x cubed over y cubed. And then, now if I add the logarithms inside, I can multiply the numbers, so that inside, if I add the logarithms, I can multiply the numbers inside. So that's going to be 2x to the 4th over y cubed. And that's my final answer. Okay, so from 55 to 68 in the book, they tell you if given log base b of 3, it's ugly 3, but that's a 3, is 0.792 and log base b of 5 is 1.161, if possible, use properties logs to calculate each of the following. So what I like about this one is, since we don't know what the base is, there's no way to do this unless you think about the properties, right? So if I'm dividing the numbers inside, I can split it up into the log of 5 minus log of 3, base b. And then we're given the log of 5. Now we just do substitution. Log of 5 is 1.6 or 161. The log of 3 is 0.792. So just punch that in your calculator. 1.161 minus 0.792 is 10 point, whoa, that's not right. 1.161 minus 0.792, that's 0.369. Okay, so this really forces you to think about the properties. So like 62, this one usually gets most people, because there's a couple other ones that you got to think about. So I can split this up. This is log base b of 3 plus log base b of b. Now, the first one, log of 3, is given to us to be 0.792, and then the base, right, we got to use that inverse property. Well, that's just b to what power is b? Well, it's just 1. So we get 1.792. So that one's a tricky one. Most people miss that one. And then the 64, I like that one. So basically, what we have to do is take the number inside and write it in, we're just given 3, 5, and then if we have things in terms of b, we can use that rule that I just showed you. So for 64, can you think of writing 45 using just 3's and 5's? And again, most people struggle with this one at first, but then I say, okay, well, think of it this way. 45 is 9 times 5, and 9 is 3 squared. So now I can split this up into, and remember the exponent will come out, well, I'll show you the next step, but normally I would just write it down once. The 2 will come out to the front. So it'll be 2 log base b of 3 plus log base b of 5, which is 2 times, we know log of 3 is 0.792, and we know log of 5 is 1.161. So punch that in my calculator. And I get 0.2 or 2.745. All right, so that concludes the lesson for 9.4. Go to my math lab, complete your exercises there, and I'll see you next time.